If the alternating series A converges, then the nth partial sum, which is equal to the alternating sum of the B terms, approximates the sum of the series with some error. And this error is equal to the difference between the sum of the series and the partial sum, which is bounded by the next term in the series. So effectively in this case, the next term in the series will be minus 1 to the power of n plus 2 multiplied by bn plus 1. And this here is what we call the error bound. So effectively this error cannot be greater than the error bound. Find the error using the partial sum up to n equals 3 and show that it's less than the error bound. So we can expand the series as follows. And in this geometric series, a is equal to 1, and the ratio between terms is minus a third. And therefore the series converges because the absolute value of the ratio is less than 1. So the sum of the series is equal to a on 1 minus the ratio, which is 1 on 4/3 or 3/4. Now you can compute the sum up to n equals 3. So that will be up to here. And I'm just going to write down the result. So that will be 20 on 27. And now to find the error, we'll just take the absolute value of the difference between the sum and the sum using 4 terms, up to n equals 3. So subtracting these two, we get the following result. And checking that this is less than the error bound, so the error bound is simply the next term in the series. So as we can see, this is true.